I'm going to talk about the structure of the cardiac conduction system and a little bit about how it operates. So, first of all, I'm going to talk about the characteristics of cardiac cells that enable it to function as an electrical system. So, the first being automaticity. So, that means that cardiac cells have the ability to actually generate their own electrical impulse. Think automatic. The next characteristic is excitability. That's the cell's ability to respond to a stimulus or the electrical impulse. Conductivity would be the third characteristic. That's the ability of the cells to transfer the impulse to the next cell. And contractility, the final characteristic, is the cell's ability to shorten or contract in response to the impulse. So that way the cardiac cells are able to generate, respond to, transfer, and contract all in response to a stimulus. So the structure of the cardiac conduction system is going to start with the sinoatrial node. That's going to be the primary pacemaker of the heart. It's going to generate an impulse at it's about 60 to 100 beats per minute. That's where our normal heart rhythm comes from. The sinoatrial node is located right up at the top of the right atrium, where it joins with the superior vena cava. So it's going to be about right here. That in turn transfers the impulse to the AV node. That's our atrioventricular node. It's located just a little bit lower, right before the tricuspid valve, in the right atrium. That is one of your secondary pacemakers. Normally, it takes the impulse from the SA node, slows it down just a little bit to give the chamber enough time to fill, and then sends it on. That one, if your SA node fails, is going to take over. It generates an impulse at about 40 to 60 beats per minute, but it's going to send the impulse on to your bundle of His. It's also known as the AV bundle. That connects your right and left bundle branches. Your bundle branches come down right between the ventricles here. It splits off into right and left bundle branches. So those continue on up the walls of the ventricles. And at the very end, they split off into what is called the Purkinje fibers. Those innervate the ventricular walls. So your node's going to travel, starting at the SA node. It's going to travel down to your AV node, into the bundle of His, down the right and left bundle branches, into the Purkinje fibers, where then it's going to cause your ventricles to contract. Here's a picture that actually shows you the conduction pathways here, except that it leaves out your internodal pathways. Just kind of generalizes there. But I am going to talk about accessory conduction pathways. So that's additional tissue that grows in the heart it's abnormal. They can conduct electricity, but it kind of bypasses your normal conduction pathway, and so that can cause arrhythmias and tachycardia. So the first would be James fibers. Those can extend from the atrial internodal pathways to the ventricles, so it just bypasses the AV node right here. It just skips it and goes straight to the ventricles. Another is the Maheim fibers. Those are accessory pathways extending from the AV node, bundle of His, and bundle branches to the ventricles. And this is a common pathway for reentrant dysrhythmias, according to our book. Another type would be the bundle of Kent. That's usually between the left atrium and left ventricle, but it can be over here on the right side. It allows for a depolarization wave to bypass the AV node, which means that your parts of your ventricles are going to depolarize early, which unfortunately means that they won't have time to fill because the whole point of the AV node delaying your electrical impulse is that your atria can contract, fill your ventricles, and then your ventricles contract.